Hey PSATs, continuing Unit 2 with Chapter 7, Linear Regression. So linear regression is what we're going to do to our scatter plots in order to figure out the equation of the line of best fit. Before I continue here, I wanted to give you guys a heads up. I know some of you have mentioned that you would rather do your own notes in your notebook, which is absolutely fine. The reason I'm having you guys do notes on these assignments are because for stuff like this, like it'd be pretty tough for you to make a scatter plot in your notebook. But if you want to do pictures you want to do it handwritten, that's absolutely fine. When you go to turn in your notes, just make sure you upload the pictures of your notebook. So if you'd rather do your notebook, that's fine. Just be cautious that it may be a little more tougher. All right, so in this situation, we have the following ordered pairs represent the number of pairs of jeans a customer purchased from various stores and their total cost. So on the x-axis, we have pairs of jeans, and then we have their total cost. All right, so I'm just going to plot these points 4, 125. And hopefully after plotting these, we can see some sort of association between the number of pairs of jeans and the total cost. And 13, 350. All right. So what I'm going to do here is draw a rough sketch. Don't do this on yours. This is maybe what I think the line of best fit would be. Something like that. Not entirely accurate. What this linear regression is, guys, is our calculator can actually figure out what is the line that best fits our data. And it does that by using this process where it'll look at residuals, which is, again, something we'll go through a little later. And it tries to see which line is the best that minimizes how far each data is from the line. Right? We want those points to be as close to the line as possible. So again, we'll get to that here in a second. All right, so let's just describe the relationship so far. Well, the relationship between the jeans and the total cost appears to have a positive association, positive direction. It's somewhat linear, I would say. And in terms of strength, I don't think it's too strong, so we'll just say like it's moderate. Not weak, but it's not too strong. And moderate in strength. So we have a positive association, somewhat linear, and moderate in strength. Calculate and interpret the correlation. Really, let's just say the correlation coefficient. So that's that R equals value. We'll actually come back to that here in a second. Because when we calculate this, it actually gives us the equation of the line. And that goes on to these next couple questions, where this next question says, what do we need in order to predict the total cost of purchasing 10 pairs of jeans? So if I were walking into the store and I'm like, I wonder how much 10 pairs of jeans are going to cost me. Well, again, what I could do is I could look at a line of best fit, and then using my line of best fit, just use the point 10 comma whatever to see, okay, at about 10 jeans, my total cost should be about $300. Assuming this line was correct, but again, that's just some random line there. So what do we need in order to predict? We need an equation or a model, or what you also call the line of best fit. All right, and right now we don't have that. but our calculator can do this. And I showed you guys last week one time how to do it, and I will show you again here. And again, we'll come back to question number 3. But on the next page, a model is, in this case, it's an equation to represent reality. Now, a linear model, very specifically for this unit. Our linear models are going to be in the form y equals a plus bx. Not mx plus b. Your calculator also gives you this option, but we don't want this option. We want a equation where our y-intercept, or initial value, is first, and then we add the slope. All right, and actually a more specific version for AP Stats is this. Y hat equals b naught, or b sub 0, plus b sub 1 x. And I'll talk about what this is here in a sec. Go ahead and write that down. What we have here, guys, we have 4 different symbols. We have x. You guys know what x is. That's just your independent variable. But then we have y with the hat on it. All right? And it's very important that we have this y hat. Because what that y hat means is that it's a predicted y value. Right? We don't know what the actual y value is. We're going to use it in order to, we're going to use the equation in order to predict a y value. This b sub 0, or also the a, this is your initial value, or your y-intercept. So it's like 0, comma, b sub 0. You guys know y-intercepts. And then this b sub 1, this would be your slope. Alright, so this is the way we actually want to write our equations. So the last question, question 4, says to create a linear model for the situation and calculate the correlation coefficient for this problem. So looking at this, guys, we want to figure out what is the actual line of best fit and what is the correlation coefficient. Well, I'm going to use my handy dandy Graphing Calc 83. So let me pull that up. And remember, most of our stuff is going to be in the stat menu, so let's go to stat. And for this, we actually want to edit our lists. So click on edit. And if you have lists here, you can delete those by just scrolling to the top to L1. So L1 is highlighted, the entire list is highlighted, and then just press clear, then enter. And it deletes the entire list. So again, I'll scroll to L2, press clear, press enter, and now I have 2 blank lists. And what I'm going to do in these 2 lists is type in all the x and y values for our scatter plot. So in list 1, what I'm going to do is type in the x values. So I'm going to type in 4, 6, 7, 7, 8, and 13. 4, 6, 7, 7, 8, 13. Now in list 2, I'm going to type in the corresponding y values, making sure that I do so in the same order. So 125, 200, 150, 275, 375, 350, Not 351, just 350. Let me just double check. All right, looks good. So once you have all your data in there correctly, we're going to go back to the stat menu. And we're going to hit on calc. And eventually what we're going to do here is linear regression. Now, it's usually option number 9, but it's linear regression that says a plus bx. Now, if I calculate this right now, guys, it's actually not going to be everything we want. So I'll come back to that in a second. And the reason that it's not going to be everything that I want is if you guys remember that before we actually run the linear regression, we need to make sure that our stat diagnostic is on. I mentioned that last week, and in order to make sure that your calculator is in the correct mode, you're just going to click on mode, which is right next to the second button. And then here you're going to look for wherever it says stat diagnostics. And mine's down here, and mine is turned on already. I turned it on last time, so mine's good to go. Just make sure that this is turned on. If this is not turned on, you're not going to get all the statistics when we run the linear regression. So please make sure this is on. And this menu may look a little different if you're actually using a physical calculator, but nonetheless, it should say stat diagnostics off or on. Make sure it's on. All right, so now that we have all our data entered in the lists, remember, I can go back to stat, and now we actually want to calculate a linear regression. So it's option number 9, a plus bx. And then all we have to do here is put in our first list, comma, second list. So I can do that by hitting second 1. So that gives us list 1. I'm going to put a comma to separate, and then I need list 2. So second 2. And then I can close my parentheses. And again, what we have here is our calculator is going to run the function linear regression a plus bx of our first list and our second list. Hit enter. Bam. Get all this. So here's what I'm going to do. I'm going to try to split screen. But, of course, there we go. Oh my gosh, that was like the easiest time. And let's see what we have here. We have an equation, y equals a plus bx. They give us a y-intercept of about 54. They give us a slope of about 26. They give us an r-squared value and an r. So I'm going to answer number 3. It says calculate and interpret the correlation coefficient. So our r value is 0.74, I'll say. When it says interpret, guys, your r value tells you 2 things. It tells you the strength, like how strong the association is, and how whether it's positive or negative. In this case, we have a positive 0.74, so we can say the association is positive, and 0.74, we just have to like think about this. Is this strong? Is it really strong? Is it moderately strong? Is it really weak? And kind of like what we said before, and I would say moderately strong. So the R value tells you 2 things. It tells you the direction and then the strength. And then we also have the equation, which now I'm going to scroll down to question number 4, which said create the linear model. Well, here's the linear model. We have y equals a plus bx. We have a, and we have b. I'm going to write y hat equals 54 plus b, which we said was about 26 bx. Now notice my y hat is predicted. It's not y equals, it's y hat. Many students get this wrong. And the reason that this is important is because we have to understand this is a predicted amount. All right. Another way that you could see this would be that since we're predicting, in this case, the total cost, you could see something that looks like this. So the predicted total cost is equal to 54 plus 26 times the pairs of genes. So both these equations are the same thing. In this case, all they do is substitute the x and y variables for what they contextually stand for, pairs of genes and total cost. Nonetheless, we still have this hat, which is a predicted. So again, if I were to actually graph this point on here, 54 is our y-intercept, our slope of 26, maybe it would go somewhere, 54 is like right there. Might go something like that. All right. And what we're going to do later in the unit, guys, is we'll actually see a lot more analysis with our scatter plot and linear graph.